So you can see here, this is the way how the wave is oscillated. So I start from here, one complete oscillation. This will be known as a periodic time. Again from here, one complete oscillation. This is a periodic time. One complete oscillation. This is a periodic time. And so on. So you can see here, T, 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 so on. If I keep on adding them, 1, 2, 3, 4, 5, 6. Yeah. My graph it is not accurate, okay? There were 7, but if you look at the question paper, there are exactly 8, okay? There are exactly 8 periodic time. And that 8 periodic time was equal to 0.25 seconds. Now let's keep it apart. Now why the hell should I find the periodic time? Now what am I requiring here? To find the beat frequency, what is required?
Frequencies.
Yeah, the respective frequencies are required. But why I'm actually finding the periodic time?
To find
And
the frequencies.
yeah, to find the frequency. Using the periodic time, how can you find the frequency?
Equation.
Yeah, what equation? What is frequency equal to in terms of periodic time? That's fine, okay.
V
Yeah,
is
it
equal.
is. That is V equal F lambda. Basic equation is Fp is equal to 1 over T. So by finding the periodic time, I'm able to obtain an answer for the frequency. So just find an answer for the frequency here. And I'm unable to draw the graph for the next one. Just find the periodic time for them as well. Just give me an answer soon, please.
Is it 14? Sir, you're muted.
Okay, sorry. There's another graph as well, right? Find the periodic time of him. Okay.
Sir, have you written that 8T is equal 0.2? seconds?
0.25.
25.
Because you
Okay.
can see, right? If I keep on adding them, it will finally equal to 0.25. Okay, so let's look at the first one. Now you just work on that. I'll just calculate the values. First one, the periodic time is
Is it
0.25
32?
divided. Yeah,
For the first one, the frequency for the first one is 32?
yeah, I think so. Because there'll be 100 part. Yeah, 32. Because 0.25 over 8 will be the periodic time. 0.25 over 8. So when you just go for the equation, frequency is 1 over t. So 1 over 0.25 over 8. I'll be having an answer like 8 over 0.25. Yeah, you'll be getting 32 hertz. So similarly, find the frequency of other one. Let's see how many periodic times are there. Just see me how many periodic times are there.
11 is there, and I'm getting 44 as the frequency.
Yeah, because 0.25, yeah, 45 is 1, 2, 6, 7, 8, 9, 10, 11. Yeah, 11, right? There are 11 periodic times. It's so narrow, okay? So if I just go around here, I'm starting from this point. Here is a periodic time. You can see there are 11 such. So 11 periodic time is equal to 0.25 seconds. Because you can see it is finally ending up at 0.25. If I keep on adding all the time, I'll be having 0.25 seconds. So periodic time will be equal to 0.25 over 11. My frequency will be equal to 44 hertz. Because anyways, you'll be getting a 4 and multiplying with 11. 4 into 8 is 32. So what is the bit frequency now? 44 minus 32.
12.
Yes,
12.
right? 12 hertz. So that's the way, okay? Just see what you are requiring and how you are going to obtain them. Then, I think I left another one as well. The near point of a long-sighted person is at 37.5. He is wearing a spectacle lens to wear clearly the object at a distance 27.5. In this state, what you do distance? So you're okay up to here, right?
Yes, sir.
If so, let's move to the next question. Before the optics part, that means with this question, there's an optic part. I'm just skipping for now. What I feel more important is look at question number. It's a small question, which let's finish that and come to here. The second question after this. The second question after this. It will take around 2 minutes. Just try that. Yes, what were the answers?
Sir, is it that potential energy question?
Yeah, it's related to potential because they are clearly asking what is the potential energy, but you have to get a small theory point behind that. I think you might have learned in the starting of your physics part. When you're learning kinematics for the first time. Did you get any answers, Silma?
Is it the first answer?
40, 60. Let's take that. Okay, so before we came to this question, if there is an object, I have dropped this object from a certain height. You might have find this, okay? What is the distance traveled in the first second? What is the distance traveled in the second second? And you might find out what is the distance traveled in the third second. So I'll just teach you a small, not a theory or it's not a shortcut. With practice, you have to just improve yourself because it's fine, okay? Because starting of your time only you deal with this question. So just try to find
Yeah.
the distance traveled in the first second. Yeah.
Yes.
Sorry.
5 meters.
Yeah, there'll be a small pattern behind them. You can find the ratio between them. They will be finding 5 meters. What is the next one?
15.
Yeah, completely 15. Here, 15 minus 5.
Oh,
So it is
that's
10.
10 then.
Then
50.
here you'll be finding it as 25 or right? I think it's 25, right? You check that. I think it will be 25. Completely, okay? Completely it will be 20. You don't have to check that. The question they are saying us is the potential energy of a particle in the first second is 20 joules. What is the possible potential energy of the particle second and the third seconds respectively? So now you should not go. You should not go for this part, okay? Now you know in the first second it is traveling 5 meters. Totally 2 seconds it is traveling 15 meters. Totally 3 seconds it is traveling 25 meters. Now I'm not speaking about the distance traveled in the n second. I'm not considering only the distance traveled in the second part. I'm considering the total distance in 2 seconds. The total distance in 3 seconds. So what will actually happen here is now you measure potential energy from this way. Height in mgh. The height is 5. Gravity is 10 into whatever mass. And if you look at the next part, the height is 15. Gravity is 10 into m. And you'll be measuring so on. But in an exam hall, you can't waste time for finding them. So I'll just say a shortcut behind them. the distance ratio would be like this. 1:3:5. Just check that, okay? I'm saying with my memory. The distance ratio will be
Yeah, so that's
1 is,
correct.
yeah?
What is it?
Hmm? Yes, what was your
1
doubt?
is to 3 is 5 is correct.
Yeah. So that will be the ratio, okay? So just remember them, okay? So 1:3:5. In the first second, it is traveling 5 meter. Then it is 15:25. And the more important point is, it must be dropped with rest. So it has to be dropped, okay? There has to be no any velocities, I think so. I'll just check that and say, for now, just remember the distance ratio is 1:3:5. So they are saying us, the potential energy here is 20 joules. So what has to be the potential energy here? And you know the distance is, now you can see, equation for potential energy is mgh. Now for all of them, this mg part is a constant, right? Okay, the same mass, the same gravity. Okay, I'll okay with this, or do you have any confusion? Fine. Okay, I'll okay with these parts. This mgh,
Yes, sir.
mng will be a constant. Okay, so only thing varying is this h. And you know how will be this? You know how this will vary? It will be varying 1, 3, 5, so on. So in the first second, it is 20 joules. What should be in the next second? Get an idea?
Sorry, sir, can you repeat the question?
It's in my file. Yeah. The question is, they are saying the first second the energy is 20 joules. And they are also asking, right, what will be the energy, potential energy in second, in the third second. So, you know what is the distance ratio? It is
60 and 100.
1:3:5. Hmm?
60 and 100.
Yeah, that's it. Okay. So with this ratio, you can see here. Only thing varying is this h. And you know how it is going to vary? 1:3:5. So 20, 60, 100. And if the first one was like 40, 120, 200. Just remember this. So the answer is the second one, okay? 60 joules and 100 joules. I'll just check that whether if you are dropping with the velocity, will it be the same? If so, it will be really helpful for you. Okay. So all okay up to here? So let's finish this here. Now I think the relativity question and that optic question is really important. I can just discuss here, but just go around the theory and just try. Relativity is extremely important. That one superb question. Optics was even. It was from a past paper. So if you're getting a clear idea on what will happen if you're using a lens, you can just try it. And what I see the most important one is the one after this. I think we have tried that, right? That pulley question.
Yes, sir, we have.
But just try it again. Okay? That's a superb question. Then, yeah, the last one, anyways.
Sir, but during the annual exam, will we get any like polygraph question like this?
Yeah, maybe. Because nowadays it's important because uh, if you want see at question number 2019 19, there was a heat MCQ. Now usually they used to give you that assume there is no any heat loss in those questions. But in this question they were not mentioning that. So you can just try that, okay? It was an MCQ. They were asking what material is it. So even I was just trying it having no any heat loss. So you won't get an answer properly. So you can somewhat about like an FWC, like a Morato paper, they have think that. So it's better if you learn everything, right? Now these are things which you already know. Only thing is they have modified it. If I just limit the amount of graph to this way, everyone will answer that. But that's why they have just increased the amount of waves to make you frustrated. And they will just make you that you won't get an idea like that. Okay.